So, hello everyone. My name is Anthony Eden. I work for Chimp. I'm going to talk a little bit about DNS Hackery with PowerDNS and Ruby. At Chimp, we actually are a top-level domain. We have the rights to sell the .mp domain, or give away, in which case we do with Chimp. So some of the problems that we have to deal with are a little bit unique amongst web applications and web providers, because we don't just deal with a single website, we deal with potentially an unlimited number of websites. And for us, one of the key tools that we found in order to provide a service that essentially looks like we're providing potentially millions of websites is PowerDNS, backed by Postgres and Ruby. So what we do is we have multiple root DNS servers that all run PowerDNS, and they're backed initially by Postgres. PowerDNS has a plugin. Is anybody here familiar with PowerDNS? Probably not. DNS is one of those black magic things that most people go, oh yeah, I do my DNS through GoDaddy. And that's where they leave it. And there's actually, DNS, whether you realize it or not, is basically, if it doesn't work, your internet doesn't work. It's the everything. You know, if I shut down the name servers for Chimp or for the .mp/TLD, can you do me a favor, can you hammer my power cord there? If I shut them down, then everything we do goes away. Chimp goes away, all the domains we serve up go away, everything. So it's a lot of responsibility to keep those things up. So anyways, what we have set up is Postgres handles static domains that never really change. So for example, the Chimp chi.mp always goes to a particular IP address. So we have a fixed A record. nic.mp, which is basically the core registry, goes to a specific address. So we use Postgres, we put the records in Postgres, we don't ever have to touch those. But we found cases where we need to do special things where you can't put it in the database because you can't generate all of the domains that can potentially exist because there are an unlimited number of domains. So what we've done is we've used what's in PowerDNS they call co-processes. And you can use any scripting language or programming language. You could write in C if you wanted to, but you could, in most cases you write scripting language, and it comes with an example of using Perl. So what I did is I converted those Perl examples to Ruby. Now this actually, get back to the Ruby sucks performance-wise. Yeah, in the case of PowerDNS, you don't care because it does an immense amount of caching all over the place. And so it rarely hits the script. So I'm going to go through and walk through a few examples. This is not from our code, however, I started with our code and then sort of ripped a few things out to give you a few examples of how it might be interesting to you if you're doing work like this. So in the first example, we use SQL, the SQL library, SEQEL, as opposed to SQL. We use that on the servers as a quick way to get into the Postgres servers, but in this particular example, we actually don't even need that. But essentially, we run this as a Ruby script. The first thing that it does really is we set the sync for standard in and standard out to true, so that means it's basically going to not cache, it's not going to hold data before it writes to those, it's going to write them straight away. Now, the co-process API basically says, okay, PowerDNS is going to pass you text. And they're one line, and they're going to pass it a line at a time, and it's going to be tab-separated text. Pretty easy to work with text. First line it sends is hello. Okay? I wish I could get this in a way that doesn't... Hold on. Let's try this. There we go, that's better. So the first example, so it gets hello. If it doesn't get that, it's going to say, hey, I fail, I'm leaving right away. If it does that, it's going to say, okay, we're firing up the custom backend. That's right here. So it writes that to standard out. Then you go down and it starts reading from standard in. Pretty simple. This is just some basic Ruby stuff going on here. We can write to standard error for log messages, or we can continue on, and we continue on here, and we basically chomp the line, split it by the tabs. If we don't have 6 args, then we send the end command, which says, I can't respond. And essentially, if the server gets to that point, it's going to send a serve fail, which is a fast fail way of saying, no, I can't respond to that query. We go down a little further, and it'll split split the query by tabs into the important ones are the Q name, the Q class, and the Q type. So that's the query, the name they're looking for. That would be something like yourdomain.com is the name they're looking up. Q class is going to be, actually that's not that important, IN in almost all cases. DNS can actually handle different classes of data. IN is actually, I believe, internet. So, and then Q type is going to be a record, which is basically a pointer to an IP address, CNAME record, which is going to be a pointer to another name record, or any of the other kinds of things that DNS can support. So once we've broken that down into an array, well, to basically into 6 elements, then we can start doing things like this, where, let's see here, that's big enough to see. Can I shrink that down just a little? If that'll work. Yeah, you should still be able to see. So what we're doing here is we're saying, okay, I'm going to use a regular expression, and I'm going to grab out, in this example, the first part of the name. So this is the third level domain. Okay, I'm going to store that here in short name. Okay. At that point, I say, all right, if you're querying me, because a query can say, give me records of type NS, or A, or it can say, give me any record type. Well, in this case, I'm going to say, okay, if you ask for an NS record, or any, I'm going to give back ns1.somedomain.com. That's my domain name servers, right? So I always have to give it, if it asks for NS records, and I have them, I need to give it to it. If it asks for any type of records, I need to give it plus any other records I can do. Now, here's the part that's actually getting interesting, why we couldn't do something like this in a database. Here we're going to say, okay, if your type is an A record, and your short name starts with letters A through M, go to this IP address. But if your short name, which is basically the third level domain, starts with N through Z, go to this IP address. So what we could potentially do here is use this for a sharding setup, okay, where it could send domains with certain letters over to one set of servers, and domains with certain letters over to another set of servers. So that might be one example, and then it has a fallover IP address. You can say, oh, anything else, send over to here. So that's for something that wouldn't fall in that. Maybe if it starts with a number, okay, something like that. And then I write a little error message here and say, okay, we sent this address for this short name, and then we actually write the data. Now in the case of that co-process API, you write literally the word data followed by a tab, followed by the Q name, the Q class, the data type that you're sending back. In this case, it would be an A record. The time to live, which is going to be, in this case, 3,600 seconds. And then that's 6 minutes, essentially, right? No, anyway, 30 minutes, whatever. I don't think about this stuff too often. The negative one we throw away, and then the address that we're dealing with. So that's going to be the IP address. So now, if I go over here, and I don't have PowerDNS running right now on this machine, but I'll give you an example of running this here. So I'm running now that little script. I'm going to grab some sample data here. And it just responded to all of that, and I'll show exactly what it did. So here are the 4 lines of what it sent initially, and then it said, okay, our custom backend's firing up, we received this record, we sent this address, and there's the data. This was written to standard out. So in the case of PowerDNS, that would actually return that record when you queried PowerDNS with something like dig or NS lookup or something like that. And so on and so forth. Then it goes end of data, we hit end. All right, now we have the next one, which is, the first one asks for Quentin, which is a Q, so it goes to the second IP address. The next one asks for Aaron, which is the IP address ending in .1, so it returns that address. And then the third one, I actually said, give me any record for Aaron. It also gave me the name server records and the A record. So that's one example of how you might be able to use it. Another example, in this case we actually do need the SQL. So I set up a little database in Postgres, and it looks right now something like this, pretty straightforward. But in this case, we actually don't need it for this example, but we'll use it for the third example. But I set the data there, and it says, okay, does the same thing essentially, reads, in this case it stores the prefix, but it says, hey, this line here, go into the table users, filter and find me the login that matches short name, okay? And then essentially it says, okay, I'm going to get the short name, and I'm going to send either the NS records or, in this case, actually we do need it because I'm going to grab the host out. So that was that host record in there. So now, rather than doing something simple, which is by letter, You could have a system that will, for example, would over time, it would shard your database. So let's say your first 100,000 users are on your first shard. And your second 100,000 users on your second, and so on and so forth. Well, you could store a record alongside of it that says, here's the server that they live on. And then you could serve them up from that. So that's another example of how to do it. And I could use the same text in the same example here. Let's go over here. So this is example 2. And I'm going to paste in that same thing. And you see here this time it says, okay, Quentin was on 1.2.3.4, and Aaron was on 5.6.7.8. That's these records right here. And those match up with what's in the database. So now we can actually return the information based on a record that we have in the database. Now the final example I want to show you that might be interesting is something we actually do use in our system. So in the case of Chimp, we basically give away second-level domains. So mine is anthony.mp. Well, when I'm testing it, I need to retain that anthony.mp, but we have a staging server, and I want to go to that. So we have staging.anthony.mp. Well, in this case, though, we still need to know that middle part, first of all, we need to know you hit a staging server. That's all we really care about. So, and we're going to keep the rest of the domain. We'll parse that in our Rails app to determine how to map you up to your data. But here you can see, right here, there's the query. So it says, if we start with staging and then the record, then we can return a specific CNAME record. Now in this case, notice I skipped the A records and I went straight to CNAMEs. CNAMEs points it to another domain. So in this case, I say, if it finds the word staging.somechunkoftext.subdomain.com, I want to send that with a CNAME record over to the staging server, and it says, okay, send back the same data, except it says CNAME staging.subdomain.com. And then you would have an else statement or else if in this case, to say, oh, do the same thing you did in example 2 if you wanted to shard to your other servers. So that's pretty much it. Essentially anything that you could do with Ruby, you could write something that could totally modify your DNS or send back custom results based on the query. So that's a little bit of DNS hackery for you. Are there any questions? If not, then I will pass. Yes, go ahead.
Did you consider bind and NS update?
So yes, we did consider bind. There's one thing that I'm not telling you that we do that wasn't possible with bind. This needed to do this. An NS update would have required every time somebody registers, we would have had to push to the bind server and basically reloaded the zone file, or not even reloaded, because a push like that isn't a reload, right? So we would have had to have something that pushes to that. In this case, we never have to touch the DNS, because we can essentially wildcard things in ways that make it so as soon as you set up your Chimp site, you're done. And if I go and I register bob.mp, well, bobby.mp, because Bob's a 3-letter and we keep those, but bobby.mp, there's no DNS change. It works right there. And so that's one of the main reasons we did it. Plus, PowerDNS is actually a pretty darn stable server. I don't know if you guys are familiar with the DNS hacks that came out last year, or the vulnerabilities that were there for poisoning and things like that. They were the ones who they fixed first. They basically provided the patch that says, here's everybody how you do it. So they're very responsive, it's a very fast server, and it just doesn't have the cruft that bind has. Plus, not nearly as many people attack it in the way they do bind, because DNS is one of the most often attacked parts of any system. So it's fundamental, right? You bring it, if you've ever seen I've been in DNS for quite some time, and back when they first deregulated, we sort of heard a little about what VeriSign had to do to maintain the routes that they purchased from, they said they bought. What was the name of it? No, for the DNS. Anyhow, they have the root name servers are like locked in vaults and stuff with biometric security. Just think about it for a second. Somebody poisons the root DNS servers, and that's it. I mean, they could essentially bring down the entire net.
there are thousands of other the root DNS servers you see aren't there are regional root DNS servers with those names.
There's actually, so there's 13 of the core CC, the root name servers that are labeled A through whatever they are, right? I think 13 or maybe more now. There used to be only 13. But the problem is they all sync from each other. So if you actually get at A,
but there's not just one A.
That'll be the case.
That is the case.
Yeah. So anyway, I find this stuff really interesting. For us, we're fortunate that we don't have to deal with that level of, because we're not that big yet. But anyway, the main reason we chose it was just because of the things we could do that we couldn't do with bind, and we didn't have to deal with the cruft of bind. So, any other questions? No? All right, I will pass it on to Matt then. Thank you very much.